All right. Welcome, everyone. Today, I just want to, walk through a couple of these concepts in your price setting firm chapter. It's relatively dense with like formulas, things like that, short run versus long run implications. I think it's best to sort of work through this table and highlight all of the implications for the formula and then the intuition behind a price setting firm. So we'll do that really quickly. And we'll work through it with our columns. So our first column here represents our quantity of inputs. And so the inputs are whatever the producer is putting into the production process in order to get some level of output. Then we have our willingness to pay, or our price. And so this is the various prices and it highlights like at these specific prices how many we're able to sell for each unit. And so we're thinking about this representing our demand curve in this case. And then we also have our total cost function. So your total cost function is given by some functional form. And just like a review, many of you have probably worked through this and feel very familiar with it, but just to highlight this, we'll kind of go back and forth between the table and a Word doc here. But for a functional form, a lot of you are probably familiar with this terminology from your algebra class, where you have a function being represented by f of x. And so what we're saying here is this is not multiplication. We're saying that f, our function, or we're thinking about our output, is a function of x. And so x is our inputs. And so our total cost in our example here is represented by the function below. So our total cost is represented by this function c of q. It means that our total cost, which is our outcome here, the c, total cost is a function of the quantity of units that we produce. And so this gives us a lot of flexibility. One, it means that even though we have this nice example here, 1000 plus 100 times q, all total cost functions may look different. And so this is just one specific example. What we have here is, the first thing here, we note that it's not multiplied. So that means that this represents our firm's fixed cost. These are all the things you have to pay prior to the production process. So thinking about the implication for building or having the infrastructure for a building to help the production process, all of those rents, those are things that have to be paid, and those are fixed. So they're not dependent on the quantity of units we produce. Over here, this is our variable cost. And so fixed costs, those are things that we can't really change. This is all like the research and development, the rental cost, all of the insurance costs. Those are things that go in and they're automatic and they're set. So we refer to them as fixed. Variable costs are things that can change. They're subject to change, and particularly in our case, the thing that will influence our variable cost is how many units we produce. And so let's take this concept and bring it back into our table. So we have this product here, and our product, we have all these various units. We think about our total cost function. Our total cost function is 1000 plus 100 times q. Noting that this is the only thing that's dependent on q, our total cost at 0 units is 1000. So that's that research and development that goes into it. We haven't even produced a unit of these goods, but we had to develop the product. Following from that point, we can see it's 1000, and then if I pull up the formula here, then you should be able to see it. Yeah, so once we pull this up, we can start to see the cells that are utilized to help build out the formula. I have my 1000, which is my fixed cost here, plus 100 times what? Times our quantity. And we see that this carries throughout 1,000 plus 100 times the quantity at that level. And so that's what we mean by these functions. In our case, they'll be very simple. So your total cost is just a function of the quantity of units that you produce. And as we go through it, let's start to break down a couple more of our formulas. This unit is like really rich with a lot of different formulas, but they're all relatively intuitive and straightforward, so don't stress too much about these. Our total cost is pretty simple. This is just, our average cost is just your total cost divided by the quantity of units you produce. So total cost divided by the quantity. The trickier one is the marginal cost, and this one's more important as well. So your marginal cost is the change in your total cost divided by the change in quantity. And so let's see how that plays out in the table. The average cost one, very straightforward. If I double click on the cell for any given unit, so for example here, at 3 units, what's my average cost? Well, I just take my total cost at 3 units, which is my C5 cell, divided by the cell in A5, which is my quantity. So total cost divided by quantity. This one's very easy. If you're ever presented with information with respect to tables, average cost locks you in the rows. So we have our total cost divided by our quantity here. The trickier one is marginal cost. Now here we note something weird. Our marginal cost is constant throughout. But let's see how we calculate this. So when we're looking at the change in total cost, because we're not working with differentiation here, we have like a relatively simplified version of the marginal cost, but we're taking the change in total cost is what's in our numerator. So what's the change in the total cost? Well, it's our 1,300. So if I'm, for example, I'm looking at the marginal cost at 5 units. So my change in total cost will be my total cost at 5 units minus the total cost at 4 units. And then my change in quantity is my quantity at 5 units minus the quantity at 4 units. And we'll always do 1 unit changes here. And that's because your marginal cost represents the additional cost of producing 1 more unit. This helps you isolate sort of what's going to be the profit maximizing level for your firm. So that's what we're seeing here with this marginal cost formula. As we move into the other piece for our total revenue. So total revenue is a little unique. It's very straightforward, but sometimes people can, this one's easy to forget. Your total revenue, sometimes represented as a capital R, sometimes represented as TR for total revenue, is equal to the price that you're selling the product at multiplied by the quantity of units you produce. And then our marginal revenue copies the same formula structure as our marginal cost. So, also very important, marginal revenue is our change in total revenue divided by the change in quantity. So let's go back to our table and take a look. For total revenue, if I double click on this cell, we can see that all we're doing here is I'm taking my price, which is given in column B, multiplied by the quantity. So again, we're locking ourselves in the rows for our total revenue here. So we have our price times our quantity, and that formula stays throughout. If I want to calculate the total revenue at 5 units, I will take my price at 5 units multiplied by the quantity of units I'm selling. Marginal revenue, you'll note, looks exactly the same as our marginal cost. It just matters the information that we're using. So here, marginal revenue at 5 units. I take my change in total revenue here. That's this first setup in the formula. It's my total revenue at 5 units minus the total revenue at 4 units divided by the change in quantity, which is my quantity at 5 units minus the quantity at 4 units. And so very easy to set these up. It's just a little tricky to think about how it's applied. And so being able to look through it in this table format can help quite a bit, especially because that's how a lot of the questions are structured. But let's go back to this last piece here. So thinking about our profit. Profit can be represented in a couple different ways. So our profit, sometimes represented as pi, is our total revenue minus total cost. Really straightforward here. If we were to utilize our example here, so this is not for all because we can have different cost functions, but if we were to utilize our example here, we can rewrite total revenue with its formula structure up here. So I'm rewriting total revenue with price times quantity. Rewriting total revenue with price times quantity. And then my total cost is just the total cost function we wrote above. So my total revenue minus my total cost here. And so, if we look at it in the table, very easy to work through. Click on any given cell. What's the profit level at, what's the profit level at 2 units? Well, it's just my total revenue column, the entry in my total revenue column at 2 units, minus the total cost. The big thing we want to note is that this is our profit maximizing rule. So let me scroll over a little bit. Our profit maximizing rule, which is the rule that firms utilize to identify, like, how do I figure out the quantity and price I should sell my product at? Firms are going to look for the point at which marginal revenue equals marginal cost. Now, you want to think about this as sort of a stopping rule. And so you can think about it in 3 phases. We'll note that at each point, like before our profit maximizing rule, at each point before this, so here at 10 units, we're able to identify that our marginal revenue is equal to our marginal cost. So we as a firm would stop here. This would give us our stopping rule. At each point before that, we have a different relationship. We see that, let's say, for example, we take it at 2 units. At 2 units, my marginal revenue is 1,700 units, meaning that the revenue that I get from producing 1 additional unit is $1,700. And my marginal cost is $100. So the cost to produce that additional unit is only $100. So at this point, if we're just thinking about at 2 units of production, I made $1,700 from that additional unit, from moving from 1 to 2, and it only cost me $100. And so whenever we see that our marginal revenue exceeds our marginal cost, we should scale up our production. So I continue to do so. I continue to scale up, and I'm just kind of looking at these 2 columns. Let's say all the way down here at 8 units. At 8 units, that 8th unit, as I move from 7 to 8, it made me an additional $500 in revenue, and it cost me $100 to produce it. As we move from 8 to 9, that 9th unit, I made $300 from, and it cost me $100. Finally, at the 10th unit, as I move from 9 to 10, that 10th unit made me $100, and it cost me $100 to produce. And so at this point, I've identified my stopping rule. I should not exceed this level of production. And we can note that as we continue past that, if we were to exceed it, that 11th unit, I would lose $100 in revenue for that 11th unit, and it cost me $100 to produce it. And as I continue to scale up, I'm just losing more and more money. So we think about this as a stopping rule because the point before that, whenever marginal revenue is greater than marginal cost, that tells me that I as a firm should scale up production. Our marginal revenue equal to marginal cost tells me my stopping rule. And then the point after that gives me a signal that I as a firm should scale back. So in our table here, it's very neat, it's very nice, but firms in real life application, this is pretty muddy. A lot of times you might jump from like this point here and you're a little uncertain, like you're uncertain about all these different variables like input costs, etc., and you might scale up your production to this point. And so a lot of times it's kind of like navigating a little bit of wiggle room. You go at one point where you're making more on each additional unit relative to what it costs you, and all of a sudden the next month you are hitting this negative point where you're not bringing in as much as it costs you to produce it. And so you have to figure out, it's sort of an iterative process of identifying and trying to work to the point where your marginal revenue equals your marginal cost. But that's our setup for this unit. It's a lot of formulas, but hopefully this table helps. If you have any questions, just reach out via email or stop by during office hours. Thanks.